My name is Taylor and this is Carrie, and today we will be discussing Croatian and Romanian post-secondary graduation rates under the indicator 4.1.2 set out by the United Nations. We will compare and contrast the similarities as well as providing some insight on what makes a good mathematical model.
These countries experienced similar data influences from events including changes in political power, additions to the European Union, and the country's individual economic distress and growth. For Romania, when looking at the graph, we can see in 2015 and 2017 areas a drop in education rates from the previous year. This is due to political instability within the country as there was changes in government representatives.
In 2011, Croatia experienced a recession due to the Social Democratic Party. Here we see a fluctuation of points. The trend continues until around 2015, where we begin to see some stability. Before the power of the Social Democratic Party, Croatia was negatively impacted by the financial crisis of 2008. The crisis caused school funding to be cut by 10%. Here we see a decline in rates.
When looking at the graph around 2020 for Romania, we can see a drastic drop in education rates. This is due to the COVID-19 pandemic hitting, which caused the country to experience significant economic distress. And when looking back in the earlier years, we can see around 2005, 2007, a drastic increase in education completion rates. This is due to Romania joining the European Union, which positively increased the economic standpoint of the country and allowed its education rates of completion to increase.
Croatia later joined the European Union in 2013. Similar to Romania, the country experienced an increase in rates. Croatia specifically saw rates shoot up and then level out.
To construct the best model, it's important to look at the manual, construct professors and TAs, and apply learning from classes. Finding past news articles and reports on events in the countries during certain periods and looking at past censuses and surveys in the countries can also provide a greater data analysis, and incorporating data and knowledge from various sources ensures that data is accurate and can help to predict future trends for the country.
Croatia displayed an increasing slope and shows a distinct curve here. Here, an inverse exponential equation was used. Since the data is bending quickly upwards, we can infer that an exponential line is needed.
Similar to Croatia, we can see when looking at Romania's graph that there's a positively increasing slope. However, a linear model was best suited for this data as there was a fairly steady increase in values over time.
This project has allowed us to pinpoint what makes a good model, things like simplicity, using reliable data, and being aware of our limitations. For starters, simplicity of the model allows us to explain our findings in a non-mathematical way. We ensure that our data is reliable by citing sources, fact-checking AI, and using other articles, like grabbing information from the United Nations database. The most important piece is being knowledgeable about the limitations presented. Realistically, a country cannot achieve over 100% graduation rates, so we must ensure that the model does not surpass 100% or go into the negatives. We watched out for uniformity assumptions like area-based graduating or location, as in urban or rural cities, leading to biased data as we assume that graduation rates are evenly distributed amongst countries.
In conclusion, graduation rates are directly affected by current world events. Financial and economic issues within the country can lead to cuts in schools and therefore lower graduation rates. The world is interconnected, especially European countries, and by comparing the graphs and yielding the same information from them, we can conclude that Croatia and Romania experience the same fluctuation in data depending on real-world events at the time. Thank
Thank
you.
you.